Well, for those of you in Europe, good afternoon. For those of you in the United States and North America, good morning. And for those of you in our Asia Pacific region, good evening. My name is Dave Hamlin. I'm with the Element 14 community, and we are so excited to be talking to you today with Texas Instruments all around prototyping an IoT moisture sensor kit. So we're very excited to have two presenters today, first of which is going to be Adrian Fernandez, who you'll hear. He is a microcontroller development experience manager for Texas Instruments, as well as Robert Wessels, who is one of the open source founders for the Energia system that we'll be discussing. So if you have any questions for any of our presenters, you can feel free to let me know via the chat window or the Q&A window. Any technical issues you may have, use the chat window, and you can get to me directly at Premier Farnell Webinars, and I'll help you troubleshoot whatever issues you may have. If you have a question for our presenters, you can use the Q&A window. That's found on the top right applet of your WebEx application. Now, a recording of this presentation is being made and will be made available on the Element 14 event page that you registered from for this particular webinar. We've also have a couple other extra things going on. First of all, if you want to road test this sensor kit, that you can do so by clicking on the link on the webinars page. I'll also be sending out a link via the chat window to where you can get more information about that. Also, at the conclusion of today's webinar, we'll be sending out a link in the chat window for a quiz to be taken for the opportunity to be put into a drawing to win an MSP EXP430FR 6989 LaunchPad. So more details of the terms and conditions of that can also be found on the event page of the webinar. And without any further ado, I'm going to turn it over to Adrian, who is going to kick off the presentation. Adrian, take it away.
Fantastic. Thanks, Dave. Yeah, and thank you for everyone joining the webinar here today. We're super excited for the opportunity to hang out with Element 14 to talk a little bit about rapid prototyping with our LaunchPad hardware development kits. We're going to augment that using the Energia software that Dave briefly introduced, which was actually founded and developed by Robert, who'll be giving the bulk of the presentation here today. But in short, within this hour, we're going to build from scratch an internet-connected moisture sensor from end to end, from an edge node to a gateway, all the way up to the cloud. And we'll actually be leveraging various cloud services as well to enable important things that a typical IoT type application is looking to do, whether that's remote notification or live visualization of your sensor data through a web-based dashboard. So we're super excited about that, but in short, we're going to be creating an internet-connected moisture sensor here today with the TI LaunchPad hardware paired with the Energia software. I'm going to go ahead and switch to the next slide there, Robert. So I'll quickly introduce myself, and I'll let Robert do the same. My name is Adrian Fernandez, and I manage the TI LaunchPad products here at TI. Today, LaunchPad is about 20 different development boards, starting at just $9.99. So they're very affordable. They offer everything you need as a developer to start evaluating and developing on a TI microcontroller. So as I mentioned, we have about 20 different variants, and you'll see a handful of them represented here today during the demo. But in addition to having various LaunchPad baseboards, we also have an ecosystem of plug-in modules, which we call booster packs. And these extend the functionality of the LaunchPad, whether that be additional sensors, displays, wireless modules, battery packs, so on and so forth. And both TI and our third-party community are contributing to that portfolio. And the goal is to provide customers and developers everything they need where they can start to mix and match these modules to start building compelling system solutions. And that's exactly what Robert will be demonstrating here today as he rapidly prototypes his internet-connected sensor network. So you can follow me on Twitter. That's my Twitter handle here. But nice to meet everyone, and I'll let Robert do a quick introduction here.
Well, thanks everybody for joining the webinar today. As Adrian said, we're super excited about showing you the combination of LaunchPad and Energia. My name is Robert Wessels. I'm the founder of the Energia project. Energia started about 3 years ago with the goal to enable the Arduino/wiring framework on the TI LaunchPad ecosystem. 2 years later, as Adrian said, we have a massive portfolio of LaunchPads, which Energia can be used with on most of them. If you'd like to follow us, our Twitter handle is Energia Project. The website will show that later. It's energia.nu. I'll let Adrian do the first couple slides, and then I'll take it over and we'll do some hands-on building of that IoT plant center.
Cool. Thanks, Robert. Yeah, and I'll go through the slides quickly here because I definitely want to give Robert a bulk of the time with y'all today. But here's a sort of bird's eye view of the ecosystem. What we offer within the LaunchPad portfolio, as we mentioned, is open source modular hardware, whether that's in the form of a LaunchPad, which has the integrated programmer. You also have various microcontrollers represented across the various LaunchPad flavors. And then you also have the extendable booster pack ecosystem of plug-in modules. Many of them are open source hardware in that we actually release the schematics and layouts, bill of materials, so on and so forth. So customers can start off with, let's say, a stack of boards and move towards production by iteratively, rapidly optimizing that solution. Software, Energia is a part of that solution. It's a very familiar, comfortable environment. It's great for testing out brand new ideas because of its ease of use. And then lastly, the engaged community. We've actually just shipped our 1 millionth LaunchPad unit. So that's a lot of developers, engineers, makers, and students out there working together and collaborating. And we've got plenty of community projects that are hosted online that can serve as a great starting point for many of the developers here. Go on to the next slide there, Robert. So here is a kind of a snapshot of some of the LaunchPad and booster pack boards that we have within the portfolio. You can see that it's a very broad offering. At the very bottom layer, we have the sort of a few of the various LaunchPads that are available, ranging from MSP430. If you're familiar with that product line, it's our ultra-low power microcontroller, all the way to Wi-Fi-enabled devices like the CC3200. That device actually offers an ARM Cortex-M4F with a Wi-Fi network processor in a single chip. So as you can see, depending on the application you're trying to develop, we should have a LaunchPad that suits your needs, whether that's ultra-low power, real-time control for motor control type applications, or safety-critical applications, or the IoT. The second layer above that are an example of some of the booster packs that are available to start evaluating and prototyping that application, whether that be analog inputs such as our ADS1118, which features a K-type thermocouple, so you can actually measure temperature very easily using a 16-bit TI A to D. We also have various sensors like the temperature sensor that you see there, displays like e-paper, rechargeable battery packs, so on and so forth. And then lastly, at the very top, we wanted to make sure that you were aware of the various wireless solutions that are available in the form of a booster pack as well. So whether that's through sub-gigahertz RF, which is what we'll be using today for some of our sensor nodes, NFC, Wi-Fi, Bluetooth Low Energy, and Zigbee, the wireless spectrum for the most part is covered in the form of a booster pack. So you can already start to imagine that as you mix and match these modules, you can really start to quickly create complete system solutions. Go on the next slide, please. This slide here, and this is I think the last one before I hand it off to Robert, is really just talking about some of the software offerings that we have. Energia, which is the tool we'll be using here today, is just one of the many software tools that are at your disposal when you're developing on a LaunchPad. The goal here is to provide multiple points of entry. With that same LaunchPad hardware, you can develop on the Arduino-compatible Energia interface, or the IDE that you see on the left. And that provides a lot of the same Energia or Arduino APIs you may already be familiar with. And then you can even take that project and migrate it to TI's more professional development environments, such as Code Composer Studio. If you're familiar with CCS, that's TI's Eclipse-based IDE, and it more or less includes the kitchen sink. So depending on the environment you're looking for, the flexibility you're looking for, you've got multiple tools available here. But the good news is that you also have a migration path where you can actually import a project you start in Energia using Arduino-compatible code and import that into Code Composer Studio. And at that point, you have the full debug capability that you may be familiar with in the CCS environment. So it provides you with that migration path, and again, that goal of going from prototype to a production-ready application. We tried to sort of enable that migration here between these two software environments. And one last thing I'll say in regards to some of the available LaunchPad software tools is that we also have a new cloud-based IDE called CCS Cloud. And CCS Cloud is all delivered through the web browser, and you have the ability of programming in the browser using low-level C code or the Energia libraries and APIs. So you've got multiple options here, whether it's Energia, the cloud-based, browser-based CCS Cloud, or the full-featured CCS IDE that can be installed on your machine. So multiple options here. And now I'll go ahead and hand it off to Robert. He'll go into a little bit more detail about Energia, and then he'll switch on over to the hands-on component.
Thanks for the introduction, Adrian. As Adrian said, we will be using Energia today to build that IoT plant sensor. I already mentioned it briefly. Energia is a derivative of the wiring and Arduino framework. So most of the code, example sketches, libraries, etc., are compatible with Energia. So we already will be able to leverage an entire ecosystem that existed before Energia. Energia is targeted at the TI LaunchPad ecosystem and BoostFX with a lot of built-in libraries that we make available. You can also add libraries that are available elsewhere. One other feature that we have in Energia that is not available in wiring and Arduino is that for some boards, we have an option to utilize an ITOS, which is TI ITOS. TI ITOS is an industry standard real-time operating system that has been available from TI for a long time. TI ITOS is not just an ITOS. It consists of a kernel, but the most important feature is the drivers for all the peripherals that exist on the TI chips. And the reason why that is important is because an ITOS, you can run or take any ITOS, a free ITOS, run it on pretty much any board. The most important thing is that once you start accessing peripherals in multiple tasks, they tend to collide. In TI ITOS, that is all hidden for the user, so you are free to use any of the peripherals at the same time in any of the tasks. Another feature of TI ITOS is that it has automatic low power. We'll talk a little bit more about that in the demonstration. But basically what it is that if all the tasks are idle, TI ITOS will try to put the board in at low power. So it becomes transparent to the user to manage power, which enables us to very, very easily run these LaunchPads off small batteries. We'll talk a little bit more about that later. Adrian had mentioned that Energia is also available in CCS and CCS Cloud. I encourage you to explore those options too, especially CCS Cloud, because it's really, really easy to get started. There's really nothing needed other than a LaunchPad and a browser. I already mentioned the TI ITOS and the multitasking, so let's look at that in a little bit more detail. Things that are seemingly easy, such as blinking 3 LEDs at a different rate, are actually not that easy to implement. If you start looking at what that code looks like, you'll have to rely on timers or keep track of time, etc. With Energia, it's actually really simple to create such a multi-blink implementation. And I'll show that live. Here is just the code already on the presentation. For each LED, we can simply create a tab with its own setup and loop. And those setups and loops will turn into TI IFS tasks automatically. So we'll look at that in the live coding section. I'll skip to the hands-on just in a little bit. There's a couple more slides that I want to show before we do that. So this is what we are going to build. At the center, we will have a CC3200 LaunchPad with the CC110L sub-1 gigahertz radio, which is a boosted backend that can be plugged into the LaunchPad. On the other side, we will have a ultra-low power LaunchPad MSP430 with FM. You'll see that there's also a little display on it, and we'll use that as well. Those will be the sensor, ultra-low power sensor nodes. I have two of them here that I will be working with. One has a potentiometer connected to it to easily demonstrate the change of the value and then that being registered at the Wi-Fi gateway. Then the other one will actually connect to an actual moisture sensor, which is a sensor that you can stick into a plant, and we'll be using that to detect if the plant needs watering. Eventually, we'll all aggregate that in the gateway and use PubMap to visualize it using Freeboard, and then Samboo to send an SMS to let you know that the plant actually needs watering. Here's a couple notes. The slides will be up after the presentation, and so a couple things here, the website address, the services that we use, etc. Then, as Dave already mentioned, we will have a quiz which will enable you to win one of the LaunchPads and get started with the Energia and the LaunchPad ecosystem. With that, I'll go to the live coding. Let's get the camera turned on here. I'm sorry, my line, for whatever reason, my line got muted. Stop sharing. Turn on the camera. So hopefully everybody will be able to see the camera. I'm not sure about what the video quality is. Hopefully that will be good enough to see what's going on. So let's get started with. Let's get started with some code examples in Energia. Let me close the stereo console. Make sure that I'm sharing Energia. So everybody should be able to see Energia. Let's start a new sketch here. And what we'll be doing is we'll be doing the multi-blink LED, and I'll just put that live here. So first, let's do a pin mode, the red LED, and set that as an output. That's pretty much all that we have to do in the setup. Now for the loop, we'll do a digital write to that red LED, and we'll say let's turn it on. Then let's delay for, let's say, 1 second. Then I'm just going to be lazy, copy, And that's pretty much all that we need for blinking our first LED. Now let's upload that and see what that looks like on the LaunchPad. And it's uploaded. You should be able to see that the red LED is blinking. Now let's look at how we create these multitasks using Energia multitasking. I'm pretty much going to create a new tab, and let's call that green LED. And then let's just copy all this, paste it, and we said we were going to do this green LED. And let's upload that and see what that looks like.
Hey, Robert, can you make sure your screen is shared? I see your video, but not your laptop screen.
Oh, okay. I thought I was sharing.
Yeah, it was up earlier during the PowerPoint.
It's sharing. Is it sharing now again?
Perfect. Yep.
Oh, thank you. For whatever reason, it disabled my sharing. So I just uploaded the green LED. Actually, let's change that to red a little bit. Let's upload that and see what that looks like. We should see two LEDs blinking at a different rate. Let me go back to the first tab because I don't think everybody saw it. So the first tab, we're blinking the red LED. We're doing that at the 1 second rate. Then I created the second tab in which we are blinking the green LED. You should now see on the camera that two LEDs are blinking at a different rate. Now let's do that one more time and say yellow LED. Now let's copy this and let's do yellow LED. And let's blink that at 100 milliseconds. And let's upload that and see what that looks like. And hopefully it's visible on the camera that all the three LEDs are now blinking at a different rate. So what really happened here is all these tabs and these setup and loops have been turned into TI RTOS tasks by Energia. So each task will now run independently, and you'll see the delays whenever all the tasks are in delay. The LaunchPad actually goes automatically to low power. Okay, so that's it for the multi-blink. Now let's go to something a little more interesting. So what I have here is a sketch with multiple tabs, and we'll go through these tabs individually. I've only enabled the first tab at this point to show you how easy it is to connect to Wi-Fi. So really all that is happening in the setup, which runs once, we're calling connect to Wi-Fi. So let's look at that function. So there's not a whole lot in this. There's a lot of printing going on. But really the essential thing here is calling Wi-Fi.begin with your network name and the password. We then wait for Wi-Fi to be connected. We'll print some dots, delay for a little bit, and we'll loop here until Wi-Fi actually gets connected. Then after we are connected, we'll go into the code where we wait for an IP address. So this waits, until Wi-Fi actually got an IP address. Same thing here, printing dots until we actually get an IP address. Then, we'll print IP address that we got an IP address, and then we'll say, Wi-Fi is connected. I'm going to use these variables in the other tabs. Then I'm not going to go into the print Wi-Fi status. Pretty much it prints the IP address, etc. We'll be putting up these sketches, and you'll be able to review them after the presentation. So let's actually upload that and see what that looks like. And let's open the serial monitor. And you can already see we're already connected to Wi-Fi. It printed the IP address, and in the loop I continuously print connected to Wi-Fi. So it's that easy to get connected to Wi-Fi with the CC3200 LaunchPad. So now let's do something a little bit more interesting here. Let me go in the loop and comment out this code because we don't want to have too much going on printing. So now let's actually look at one of the sensor boards. So this is the sensor board. I have a little potentiometer connected to it. Hopefully that's visible for everybody. It's a sliding potentiometer. There is a display on the board, and then on top of it we have the CC110L booster pack, which is a sub-1 gigahertz radio. That same booster pack is also on the CC3200 LaunchPad, and we'll be communicating with sub-1 gigahertz from the sensor node to the Wi-Fi node. So let's look at that sketch that runs on the sensor. It's actually very, very simple to get something over the air using these combinations. So it's really easy to send sensor data to the CC3200 and then eventually to the cloud. So the lines that really matter, this is just for the LCD. It's not as important as the radio code. So really the only thing we have for the radio code is, again, a radio at the beginning. We give it an address, the channel we want to communicate on, and the power, output power that we want to use. I do have something called a TX packet. I won't go into it in detail, but basically what it does, it has an ID, a name, and a value, and I will be sending this structure over wireless to the CC3200 gateway. So that's pretty much it for the setup. The only importance here is this line where we say radio.begin. Then in this structure, we have a value, and what we're going to do is we're going to analog read the potentiometer voltage, and we are doing that on pin 2. So the potentiometer wiper is connected to pin number 2. I'll use some LEDs to indicate that we're actually transmitting. I'll print the value of the potentiometer to the display. And then really the only important code here is that radio transmit. So basically this sketch could only be a radio.begin and a radio.transmit if you wanted to transmit static information. So that's pretty much it for the low power sensor node. I've already programmed that sensor node with this sketch, and you'll actually see it up and running. It might be, hopefully the display is visible. If not, then we will be displaying those values in the serial terminal in a little bit. So if I change the slider, then hopefully you'll be able to see that the value on the display changes. Now let's look at how we receive that information. I've uncommented it, so let's actually uncomment all this code. And really, again, what happens is there is a radio.begin, same thing, address, channel, power. Then on the receiving side, we call something radio.receiver on. And again, we have that same packet structure that we had on the sensor node. And if there is something received, then it will put that into that structure. And that will allow me to reuse it in some of the other sketches. So in this case, I'll set the ID to whatever I set the ID for the sensor node. I'll put that in the structure. Then the name, we're not really using the name, but just to give it a name. And then I'll get the value of the potentiometer into the sensor's array. And the only other thing that we do is do a digital write to indicate that we actually did receive something. So now let's upload that to the gateway and then see what that looks like. So we'll see again that it's trying to connect, it's connected, and there we go. We are getting values from sensor node 0. Its name is multi-sensor, and the value, if I change the potentiometer, we'll see the value change. So that is the same thing that will be happening with the actual plant sensor. I'll bring that in view in just a little bit. So that's pretty much it for receiving data from the sensor node. And again, these are in two separate tabs, which means that both of these are now TI RTOS tasks. And you can already see that it becomes very, very easy to segment your application into different tasks. For example, this radio part, what I did is I pretty much took an example that came with the radio library, copied it and pasted it into this tab, and that's how easy it is to pull pieces from examples into your sketch. Now, in the traditional way, I would have to, pull this code apart, put it all into one sketch, and as you'll see, as we add more and more functionality, it will become rather hard to manage because there's so much code and there's so much stuff going on. So now let's actually look at PubNub. PubNub is a publish and subscribe service that we will be using to publish the data that we receive from the sensor nodes to the cloud, and then ultimately visualize that with Freeboard. Now, let's uncomment that code, and we'll see again that there's not a whole lot going on. So let's quickly look at what the sketch actually does. Again, there's a really simple function, begin, to initialize the library. I give it a publish key and a subscribe key, which are used to identify, between different streams of data. Then in the loop, we'll go into this wait for Tambu a little bit later. What I do is I construct a JSON object like this analog array. And you can see that right now I have place for 3 sensors. Today we'll only be using 2 sensors. I won't go into the details, but eventually I go through all the sensors, in this case 3, and construct this string that we will be publishing to PubNub. Then the second line that is important in the loop section is the PubNub publish. And it's really as easy as calling PubNub.publish with the channel, the message, and then there's a timeout for if the publish doesn't succeed. if that actually succeeded, I'll stop the client and continue. If it failed, then I'll print that, we might have some network problems. So now let's look at what that looks like. And again, I'm connecting to the network, and you will now see, so now and then, a publish. And let me actually scroll, stop the auto-scrolling. It says publishing message, and you will see that that sensor value that I read here is actually now in the array that is going to be published to Farnell. Okay, let me share my browser here so we can have a look at the actual topknot. So here I have the topknot publish and subscribe keys. Before we do that, let's actually look at the debug console for topknot to see if we're actually receiving the data that we hope to receive. Select my key, and let's look at the debug console. Now, say add client. And here we go. We're seeing that data is being received from the CC3200 gateway. So we should be pretty much up and running. The reason why I copied that subscribe key is because now we are going to create a new freeboard dashboard. So let's call it webinar and say create new. I'm going to add a data source, which in our case is topknot. I'll call it webinar. And then this is my subscribe key, and we have sensors. And you immediately saw that the time here changed while it was last updated. So that means that we're actually receiving data. So let's add a panel. Let's make this a little bit wider. Now let's add a graph. Let's use the sparkline. Title, answer 1, value. The nice thing about Freeboard, it already knows where the data is coming from. And in this case, you can see it's again the same structure as we saw in the sketch. It says analog, and I want that first sensor. And I say save, and there we go. If I now change the potentiometer, you'll see that the line drastically changes, and move it up again, and the data changes. So this is how you can easily visualize data. And let's actually go back to the Energia. So this is how you easily visualize data using topknot and Freeboard. There are many, many other graphing publishing services out there that you can also use, and most of them are as easy to use as the ones that we're using now. So now let's actually bring in that second sensor. I'll move this one out of the way. Now let's bring in the second sensor here. So this is the sensor that actually has a cup of water. You can see the plant sensor in there, and the LaunchPad itself, and it's exactly the same as the other LaunchPad. So now let's plug that one in, and we should see that, we stop the auto scrolling, that we went from the second sensor, which was 0, suddenly that value started changing, which is now the value of the actual plant sensor. And you'll see that the value right now, let's wait for it to publish again. is about 1,800. If I pull it, then you'll see that it changes from 1,800 to 4,000. So that indicates that, water, full in water is about 1,800, 4,000 is about without water. So now let's go to Tembu. Tembu is a service aggregator, as they call it. So what Tembu does, it offers a common API across a lot of web services. They call it Choreos. So they aggregate things like Yahoo Weather, Google Spreadsheets, other things like FedEx notifications. So this is, makes it really easy to not have to write code specific to a service. You can just use Tembu as the aggregating service, and it becomes really, really easy to use all those services. In our case, today we're going to use a service called Twilio. So what is going to happen here is I'll uncomment the setup. In the setup, I'm going to wait until I'm connected to Wi-Fi, because before that, there's no need to publish. Now, let me uncomment the Tembu part. So you'll see a whole lot of code here. The nice thing about Tembu is what they do, and I'll pull it up later if I still have some time. Tembu has a website where you can go, select one of the services, fill in your information, and then what it does, it generates this sketch for you. The only thing you have to do is just to copy-paste that sketch from the Tembu website into Energia, and it's pretty much ready to go. I don't have to do a lot. In this case, the only thing that I changed was that I put a condition here that if the sensor value of sensor 1 is higher than 3,000, remember that with water it was about 1,800, without water it was 4,000, so 3,000 should trigger this part of the code. I won't go into all the details since it's easy to generate on the Tembu website, but really what we're going to do is we're going to send the text from a number to a number if the plant actually needs water. So if it's without water, it will send you an SMS, and you'll see that the text that we will be getting will tell you, please water me because I'm about to die. So let's actually run that as well. The serial console again, going to connect to Wi-Fi, and it's still publishing to freeboard. You'll still see that if I change the potentiometer or one of the values or one of the sensors, then it will show the graph. So now let's add another one, which is for the second sensor. Plant, value, data source, webinar, analog, and in this case it's sensor 1. And let's save that. And we already see that the value that I was reading in the console, again, is the same value as I see in my pipeline. So now let's actually pretend that the plant is going to go without water. And I'll do that by just pulling out the sensor out of the water. And that will change the value to 4,000, hence, triggering this part of the Tembu code. So let's give that a try. And you should see that, I don't know if that was, if you could hear it, but I just got an SMS, and I'll show it later, in a little bit. But you see that, there was another one, that I just triggered the code, and this is pretty much what it prints, telling me that it did send it up to and Simbu actually triggered an SMS. So let me see if I can actually show you the SMS. Let's see if this is visible. But you should see all the SMSs that I just got, and it will say sent from Twilio sandbox number, because I'm using a trial account, with exactly the text that I put into the sketch. So as you can see, it is create these IoT sensor nodes, gateways using Energia. These sketches can be put together in about an hour. And that shows you the power of the combination of Energia, the LaunchPad ecosystem, all the web services and libraries that are included in Energia. It enables you to rapid prototype an full IoT system. In this case, we only use 3 sensors, but you can imagine that I can have multiple sensors attached to it, and it doesn't have to be multi-sensors. It can be door sensors, it can be light sensors, etc. So that's pretty much all I had to show. I think we are going to open it up for questions at this time. If you have questions for either me or Adrian, I think Dave, we said that we would put them in the chat.
Yep, there's already a couple questions in the Q&A. You can also use the chat. We'll comb through those.
Okay. Let's see if there are